Aha! There we are. Now we're live. Haha. Beautiful. Hello, everyone. I'm sure it'll take some time for people to roll in, but we will take that time and we'll give you guys some time to roll in and we'll, jump into Auditing Drac Sucks. So, while I'm waiting for you guys to roll in there, let me go ahead and pull up the site. So here we are. Drac Sucks. DraculaSucks.com. Interesting kind of product. In this case, it is a deflationary token with a built-in burn option. So, kind of an interesting one. Hello! Hello, people! Thank you for joining. It's early. It's first thing in the morning, getting an audit out, getting Drac Sucks taken care of, and then we are, then I got a bunch of meetings and development to do. I've got a bunch of things going on, little hiccups in some of the plan there. Everyone's been very, very patient on us getting the auditing platform out, getting chain developed, and audit DAO. Fortunately, a lot of that overlaps, but I do want to make sure I get back to that. Hello, LD, hello, Sing, hello, Oliver, hello, everyone. It sucks, but it's not bad. See, this is where their premise for the DRC token is as a deflationary token, but they added kind of a gamification feature where you have this drain option. So if I get that nice and big there, so hopefully it can be seen. There we go. Then, yeah, it basically shows that there is a reward in each of these pools. If you're in any of the pools other than the Drac ETH pool, then you have this drain option. In this case, it will actually take off some of the rewards and burn them. So that way, kind of adding a gamification component to the deflationary aspect. So, but I am not here to necessarily get into the tokenomics of everything. I want to dig right into the audit itself. I got lots of stuff to do, so pardon, I don't mean to necessarily cut it short there, but everyone wants to know, does it work? So, as is typical, I start off by going to the website. Let's actually make sure that we are checking what addresses this thing is communicating with. That way we can be absolutely sure that we are looking at the right stuff. Now, in this case, here, let me make that also bigger if I can. Yep, there we go. Woo, there we are. So, in this case, they've got some information on the various pairs. That's the first one we start off with. I've made a little list here of them for my own notes. These are all the various things that they're talking to. Some of them are not Dracula specific, so to be clear, the Uniswap v2 router, but had to go make sure, alright, are you actually talking to the Uniswap v2 router, or do you just say you are? They are. They're actually talking to them. Hello, Modified. Glad you're here. Hello. We want your audit for Wise. Okay. Cool. I can definitely do that. You guys can reach me on Twitter. You can definitely always send an email to audits@chain.church, but probably Twitter might be a good place to start off with, just to get my attention there, and boom, we will get you set up there. Alright, so, with that, and I pass out wrenches to anyone that helps, so appreciate it, thank you. Oliver, I don't know why your messages were retracted. They were perfectly nice, but alright, if that's what you want. Alright, so, as I said, needed to go through, make sure that we're looking at the actual addresses this thing's talking to. As you can see, it's got some links here for Etherscan and such, so those are handy. They do match up to the addresses that it's actually talking to, so good. They're being clear, forthright, transparent. We can see, pardon there, that's just it going through bytecode, and bam! Here is most of what it is communicating with. Now, you might be wondering, like, wait a minute, why is there this main fork net? Well, to be clear, that main net fork, that is reporting or talking to typically a local instance. The port address on there is, if I remember right, the default one for Ganache, so they just had in their code an ability to use this locally. Simple enough. Thus, If you wanted to pull this down and try it out yourself, technically you kind of could. You just have to change some of these variables. They do have here the mainnet for getting information on Infura. That way they can get info on, well, the project and various things they want to watch. And the rest of this is, well, all the various tokens and contracts that they're speaking with. So, like I said, some of these are not, actually a lot of these are not Dracula specific. They are things like, the Uniswap router, the Uniswap factory, Uniswap itself, or some various dexes on there. A lot of these, though, are. And so that's where we're going to dig into exactly how those are set up. So like I said, I got those over here. Been verifying them, confirmed that yes, these do match up to the various contracts that they have provided the source code for. Also went through the source code on Etherscan, confirmed that, yep, the source code that is on Etherscan matches up to what they provided in their repository. So with that, we can jump right into what is going on with the code. So, as is typical, I pulled it down. I started going through the code. While I was going through the code, I just ran MythX on it in the background. Like I said before, this is not the end-all, be-all of reporting. This is mostly just used as kind of a guidepost, like, alright, well, which things should I look at first? Which things are high priority? What sort of stuff might I be able to expect to find? And so that's where, digging into it, it technically starts with this vampire adapter. As you can see, pretty much, MythX is reporting almost no vulnerabilities here. They claim there's some low-level ones, but as I bring that up, again, that's why we need human beings involved in this, because we actually have to confirm what these values are. So, for example, when it's saying something like potential use of block number as source of randomness, it doesn't actually know what that's referring to. For example, it just knows, oh, you're getting the block.number variable from the system, and therefore, oh, thank you. I'm glad that you're enjoying this. I'm glad that it's useful. A lot of people have been saying that they've been inspired by this. Telecos DAO, Data Lords is over there working with them. So I've been very, very flattered that, a guy that says he was inspired by my work to get back into development and get up to speed is now also working on his own DAO. Been speaking with them. So, man, I am just so tickled that my humble little attempts to educate and provide security are really getting people out and doing stuff. I love seeing people do stuff. Do all the things. Do all of them. Well, alright, all the nice things. Don't do the mean things. Well, alright, you can have fun banter, but, don't do the scummy things. Alright, anyway, like I said, these are guideposts, so as you can see, for the most part, this is just kind of a false alarm. It's saying, wait a minute, you're using block.number, that people typically use that as a source of randomness, therefore that's not appropriate. They're right, it's not, but we don't have any randomness in here, so not critically important. So that's where we, having looked at that and seen, okay, well, MythX doesn't really have anything to say useful on this matter. It brought us some warnings, hey, double check this stuff, but overall, meh, not really anything critical in there. Thus, we do need to dig into the code. So, I'm starting from the bottom here, and we'll be going up. There's a lot to go through, so I don't mean to make it quick, but as you can see, it's also fairly short things. For one, we see a lot of these use of these low-level calls here, this static call. So whenever you see something like this ABI in code with signature, that is where it is, well, to be honest, doing a rather low-level call there, where it's reaching out to the address, in this case, what it's marking as the victim, and is making that static call, namely making the point of, like, I want to go talk to this function over here on this address. And you could use things like interfaces for that, but this actually works out when you're not entirely sure what it is you'll be talking to, or there might be some different changes. On top of that, this also works out as a much more efficient call. You can use the interfaces to handle that. That makes things a lot easier, but typically doing a direct low-level call like this with the API will usually result in it being a little more efficient. And not that much, but, every little bit can help. So in this case, they're doing a confirmation here to say, alright, I want to do a call out. I want to actually try to call this reward token, get a result back. Thus, it is confirming that, yes, we were able to call out, and is able to get that result of success or, well, the actual result. From there, it's requiring that, yes, it was successful to make that call, and in this case, just gives you an error if that doesn't happen, and then goes ahead and decodes the response. That's what the ABI decode means, is saying, okay, take the result here and actually decode that, and let's go ahead and decode that as a, well, an interface to an ERC20. So, nice safe stuff here. On top of, or I should say, nice implementation here. We know this stuff is safe because typically they're all views for the most part. Actually, they literally are all views. Well, except for this one right here, sell rewards for WETH. But in that, we do want to still look at the views, even though we know that they can't really be a vulnerability. No one can hack something through a view. We do want to make sure that they are actually reporting things properly, because that is potentially somewhere, again, not happening here, but that's something to double check to see, well, how are they actually reporting information to me? Are they giving me false information? These guys, they're giving us clear, accurate information. We can see that in all of these cases with pool count, with the sellable reward amount, with the lockable token, locked amount, deposit, all similar things. They're passing in a victim. The victim is a type that they have in the code here that is, well, as you can see that contract for victim. In that case, it is sort of using this as that point of saying, all right, we want to have the type here, but rather than define a bunch of interfaces, they just went with the ABI encoding. So, for each of the view functions here, straightforward, accurately reporting everything. The one function here that modifies things is the sell reward for WETH. That's one where they're taking the victim, they're taking the reward amount, they're saying where that needs to go to, and boom, they are making that low-level call to do the sell reward for WETH. In this case, they are passing in, as you see, because we have to define the variables that, or the arguments that need to be passed in, then they're stating which ones those are. So that matches up to the parameters that are being passed in. Good, straightforward. Upon that, they're confirming the success. Yes, excellent. And then they're returning the value. Marvelous. So in this case, I like they've got a lot of good defensive programming here. They've got a lot of these require statements to make sure, yes, things do work. So every time something goes through, every time they go to make a change, they're double checking, did it actually work? Yes, it did. Great. We can go ahead and return the value. So I like that bit of defensive coding there to make sure everything's functioning properly. So again, pretty straightforward. Not a whole lot going on in here. We got mostly view functions. For some of the others, we've got withdrawals. So things like deposit, where it is actually making a change. Again, it's making that delegate call out to a victim to say, all right, well, here's what we want to pass in. So that's where we'll need to actually look at the contracts that are using this library. So again, to be very clear here, this is where the vampire adapter, this is a library that's going to be imported into other contracts, so they can use this to be able to interact with things. So down with the stuff that's making actual changes, we have the deposit. Again, very straightforward, calling out to the victim. Similar point here, just calling out with the ABI encoding. There, as you can see, they've made sure to make things very simple and straightforward. So that's nice. Without a lot of complexity here, then that means there's very little that can go wrong. So that really, really helps. But important to make sure we're looking through this, and kind of why I'm starting here, because as we go through the rest of the code, we're going to keep seeing references to this vampire adapter. And so we want to make sure that we understand what's inside these and that they're safe. And I tend to follow the path of look at these things first, confirm that, you know, these reused functions are well implemented, so that way later on when I see them elsewhere, I can just know, okay, I don't have to dig through and figure out what that thing's doing. I already looked at it. I already confirmed that it's safe. Alright, so, again, pretty straightforward. Yes, there is an emergency withdrawal. I do like in the emergency withdrawal here that as far as, you know, setting up that emergency, it is setting up the actual address that's going to be pulled out. And so this is where, in getting the victim and the pool ID, it is sending out that emergency withdrawal, and we'll be able to see exactly what that result is. Now, mind you, this is one of those cases where, as we can see, it's returning the result of that outside call. So we're not entirely sure at this point where that emergency withdrawal is going, so that's where we'll have to go check when we see the actual implementation. I can tell you it's going out to the investors, or the buyers, but, again, that point. Oh, well, thank you. I'm glad that you're finding it interesting and educational. I appreciate that. If this inspires you to do any work, any projects, please let me know. Always happy to promote, always happy to help out when I have time. I'm just very, very busy right now. So, moving on then to the next one. We've got a time lock here. Time lock is, well, being used for locking up some of the tokens, especially some of the team parts. They've got some nice points here where they have some role-based access control and admin that can actually control the system a bit. That way, well, you know, we can know exactly who is managing things. On top of that, they have a pending admin and a delay. So that is nice. That shows that if they are going to be swapping admin, then there will be a delay in making that happen, and thus everyone can know if they're watching the contract, watching the logs, to see, all right, well, they're making a change. That change is about to happen. Therefore, boom, I have time to respond, which I like. That means that, you know, there's no way that they could sneak in. As long as people are paying attention, there's no way that they could sneak in and make some weird change that we're not aware of. If they go to make a change, then it's going to be put on a delay. People that are paying attention will be able to watch this, and boom. Here we are. Why this emergency withdrawal doesn't have an implementation to automatically refund to all participants. Okay, so in this one, to be clear here, when we were looking at the emergency withdrawal, we are looking at a library. And so in this case, when it's going through that emergency withdrawal for that function, notice that it is calling out to that emergency withdrawal for anything that is using this particular function. And so in this case, we need to go, we'll know what is actually happening when we go over to the usage of this particular function. And so right now, we're just looking at a very basic implementation, kind of like half the usage, to be honest. Because as you can see, when it goes through the emergency withdrawal, it doesn't really do, and like as you can see here, in this implementation, it doesn't actually send it anywhere. That's the thing. Like, why is it not sending out to the, you know, buyers? Well, that's because right here in this implementation, it's not going anywhere. What we'll see when we get into the pools is how the emergency withdrawal is used. So that's why we don't see it right here. We'll see that coming up when we look at the various pools, the places where this is done, and see, okay, when you reuse this library, what do you actually do with it? So this is a good software design where they have a pretty standard reuse implementation that, well, or implementation they want to reuse elsewhere throughout the project. So they're just consolidating all of the parts that are going to be the same into this one function. And therefore, they can just reuse that elsewhere. So that's why we don't see this point yet. Well, why is it not just sending out to buyers? That's because this isn't the function that does that. This is just the function that handles the very basic check of, okay, can I get the funds out, or can I go get the funds out, and let me make sure that I do a check that that worked properly. We're going to see later on, like I said, in some of the other sections that say, yep, there, when you call this, we're going to withdraw that, and then we'll see where that gets sent out to. Alright, so, hope that answered the question there. In here, with the time lock, as I said, they got things running on delay as going through it, so we can see things here like when they're setting the delay, when they're accepting the admin. The accept admin is the very first one. As you can see here, it is actually making sure that in setting this up, that the pending admin is the same. That is going to make sure, yes, you are set up to the pending admin. It's going to set the admin to the message sender, and going to go ahead and set that for the pending, or set the pending admin to address 0. Again, this is just where it's being called from the initial setup from here. After this, it can't be run anymore, because when it's first set up, and they're constructing this thing, and they're initializing those points, see here, admin initialized false, that this can't be changed after the fact, and is just setting that the very first time, okay? So, in setting this up, it is really just setting that up when it's first deployed. So from here, in accepting the admin, that's saying, okay, if, and to be clear here, it is establishing that when they want to change the admin, then the address that's being set as the admin has to come back and say, yes, I am accepting the admin. So to be clear here, that's why yes, it is making changes, but it's only making changes after someone has set the pending admin. And so then as we go down to the pending admin, this is where we want to be cautious in how that's being set up. So for one, it's confirming that the address the admin initialized needs to be true. So in this case, it starts off as false. So it's saying, all right, the first time I'm running, I'm not going to run this first one, I'm going to run this second one. And so therefore it's going to check to see, okay, are you the actual admin? Yes. Cool. Then go ahead and say the admin has been initialized. Cool. Then go ahead and set the pending admin to the income pending admin. Alright, so this is where it's just set that pending admin. Pretty straightforward. Now, in doing that, that's where we can see here that in setting the, or accept admin, they would then, after setting the pending admin, have to come back and say, yes, I am accepting that I can be the admin for this. Straightforward. Alright, so, moving on. This is another one where this whole thing for the time lock is actually lovely design in this case, because as we look through it, it is queuing up transactions and then executing them later on. And so we can see, for example, in the execute transaction, that it is actually confirming that there are transactions queued. And so again, this is a nice design here, where if they want to do anything with the time lock, they first have to queue up the transaction. And queuing up the transaction, they're confirming that, yes, you're the admin. Alright, cool. We're going to double check exactly what transaction you want to execute. Again, this ABI encoding with the KEKCAK 256, that is creating the transaction hash before it goes out. Alright? And so that way it's queuing up, and storing the transaction hash is kind of a way to execute the transaction. It's a very low level one, but again, this whole point here is to say, alright, we need to add in transactions to deal with the time lock, like when it finally expires and they can withdraw. And how we're going to handle that is by queuing up the transactions that we want to execute, and therefore they're in place. This way, it is also establishing what the ETA is. And so that way it's confirming, okay, you've got an ETA, I need to make sure that the ETA for running this transaction, like when you would like to be able to do that, is at some point in the future. So this is what I was saying, where they have those delays in place to say, look, you can't come into this and boom, 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 execute a bunch of transactions that are going to screw people. There's a time delay on these things, and so that way, if you're watching any of these contracts, watching the transaction log, like if you use Infura to get regular information or have that posted, then this would be able to tell you, okay, they've queued up a transaction, and it can't execute until some point in the future, giving you time to respond if necessary, which I really like. I mean, that indicates that they're trying to be forthright, they're trying to be honest, because they're giving full disclosure, full transparency in everything that's happening, and because nothing they're doing is going to be that time sensitive, they're accepting a delay in their operations. That way, nothing gets done too fast. So again, queue transaction, just setting it up. In this case, it looks like they're returning the transaction hash so they can know what that is. Also handy for having things report out. They got a way to cancel a transaction, so they put one in and then decide, okay, that's not good. Let's go ahead and take that out. That's what's happening here with the queued transactions. So with queued transactions, they're marking that as true to say, yes, we would like to execute this one. If when it comes time to not execute it, they're doing it as false. So no, we do not want to execute this transaction. Then we come to the actual execute transaction. In here, they're again doing that transaction hash encoding, but if you remember right, that transaction hash encoding is the key through the map up above, so they need to figure out what that is. When they're executing the transaction, to be clear, they're sending in the same information that they did to queue the transaction. That's what's happening. Then they're going through, figuring out exactly, alright, so which transaction, or what's the transaction hash, so I can interact with that. They're double checking in the queued transactions to say, okay, are we actually supposed to execute this one? If not, like if it comes back as false, or false saying, you know, null, there's nothing in there, then saying, wait a minute, you didn't queue up this transaction, you can't execute it. Alright? Then it's double checking that block timestamp, confirming, okay, is this thing actually appropriate, or has we actually run through the delay, and therefore we can actually unlock this thing. Alright? And then adding in the grace period, they're actually defining a, well, like it says, grace period, a period after which it has a, they say they want to execute the transaction in which they can actually execute the transaction. And so if we look up above, we can see that the grace period is set to 14 days. And so that's where the minimum days, or the minimum delay, 24 hours, maximum delay, 30 days, and a grace period of 14 days. So they can queue up a transaction, and then they would be able to execute that from when the ETA of when they say they like to execute the transaction up to the grace period. And we can confirm that with how that's being executed. We can see here that they're marking that, yes, the transaction should not be executed anymore. Handy. In the queue transactions, like I said, they're confirming that, yes, it should be executed, and then they're saying, yep, that can no longer be executed. This is a good order of operations here, because this is making sure that if something happens, like they have a re-entry problem, it comes in, and they've already marked the transaction as not to be executed. And so that way, it can't be executed again if someone re-enters into this function. Now, from there, they are confirming that in the, where do we have that signature? Yes, they're confirming from the signature of how that's being run that, yes, that is correct. They're, from getting the call data here, they're setting that to the actual data that should be sent in, which is for the arguments. And then for the call data, they are setting that to, if that is 0, they're setting it to the data being sent in. If it's not 0, then they're actually looking at the signature and figuring out what that call data should be. That's what the bytes for is. That's what the ABI encoded pact is doing, and saying, all right, convert this over into the proper encoding that Ethereum uses, or Ethereum uses, or Solidity uses to be able to make these calls. Then they're doing that check to say, okay, go ahead and call the function. And that's why it looks a little weird here. If you guys are familiar with the Ethereum developments, like target.call, what the heck? Well, this is a generalized way to call a function. This is where the value is going to be exactly which ones you're trying to call, the call date, or I should say, exactly which call you're trying to make, and then the call data is to say, all right, here's what the actual call to that function is. And thus they're getting that back, that's staying as bytes, and in this case they're checking the success to confirm, did that actually work? Great, awesome. And then they've got the return data where they are sending back that information that came back from the transaction. Pretty straightforward. And then they get block timestamp is just a generalized operation for getting information about when this block was mined. Useful for keeping track, especially since we don't have real clocks on blockchain. We just have to go by when the block was mined, and there can be a delay there. Alright, so this is the big one. This is the Master Vampire. We can see here that it's got the vampire adapter that it's using for victim. So we already saw the vampire adapter in there. Oh, thank you, Lambo. So this is where we've got the vampire adapter. We're actually going to see its usage here. So you were curious on like, well, what's going on with that withdrawal function? Well, or the emergency withdrawal. We're going to see that usage here and can confirm that. It's got some structs. This is kind of like objects. They're data structures. So we've got a type here that we're naming that, and then values that each instance of the struct can maintain. So we've got information about the user, namely the amount and the reward debt. I've talked about that before. Very common to use reward debt because, again, we don't know when a reward is going to be calculated. We don't know when a block is going to be mined. Therefore, we want to keep track of how much is this person due based on when we last calculated what their reward is. So very common to see that usage in contracts. And again, pool info, information about the pool. They're calling that the victim. The pool ID, the reward per block, last reward block. Again, very typical in calculating the rewards. All right, when was the last time we calculated it? Cool. How many rewards should we be offering per block? Great. Let's go ahead and use that to figure out we'll use that along with the account Drac per share to figure that out. And then if there's a drain, they've got that reward drain modifier and that weth drain modifier. Alright, so with that, we can move into what is actually happening. Oh, that's cute. They made a little ASCII art bat. These guys are kind of old school, or at least they're familiar with old school. It's been a long time since I've seen a lot of ASCII art. It's kind of a lost art. I mean, it takes some real talent to kind of put that together, although we got plenty of generators now, so. Alright, anyway. Yes, thank you for reminding them on the tips. I am a broke doge. I spend a lot of money trying to help people out and solve problems and whatnot, and I try not to make too much of a big deal about getting paid, so I get screwed sometimes, but oh well. People get help, and it generally works out. And generally can turn over decent revenue anyway, so really that's the kind of the important part. Anyway, moving on. Not talking about my life problems. We've got our Dracula token. Yay! We'll be looking at the Dracula token coming up. We've got Weth, and we've got the Drac-Weth pair. Nice, so we can keep track of that. The drain address. This is going to be information about, like, where are we sending that to. So this should be burning things, so we should see that that's going to set up to an actual address that, well, should be the 0 address. The pool reward updater, the dev address. As we can see, these are, when placing them in, we've got down here where the dev address, when it's first set up, is the message sender. The actual drain address is the one they're passing in as the argument there. And so we can look at the contract and confirm, like, okay, well, what are you actually set to? Well, that's actually set to address 0. Straightforward. And so this is where they're just kind of initializing things in the constructor with all that information. Some of this is hard-coded because, well, to be honest, they're not changing. They're talking to wrapped ether, so they can just, boom, put that in there. I like seeing this as a security measure. That way we know exactly what it's set to, and we know that they didn't have a chance of changing anything. All right, so from there, we've got our, where were the other information? Yes, dev fee 8. That is going to be used elsewhere in the calculation, so don't think too much on exactly what the value is right now. Let's actually take a look and see what are they going to use that for. And in here, they got the reward pool limiter, so that's where they're going to be putting a check in to see, okay, how much are we doling out? Let's put a check in there to make sure that we don't inadvertently, like, dump a whole bunch on the market outside of what the tokenomics plan is. Again, good defensive programming. Information on the pools, we saw that up here in the struct, so that's the array keeping track of the pools. And within that, we then also have the mapping for the user info, so it's keeping track of us with a integer, and that is getting us through to the actual address, which then gets us through to the actual, well, user info. Straightforward. Some nice events. I like good wordy contracts, and pretty standard setup here of only dev, only reward updater. Alright. Pretty straightforward. It's confirming that, yep, the message sender should be the reward updater, and the message sender should be the dev. Alright, simple enough. Now, like I said, I already covered the constructor, so simple, straightforward, not a whole lot going on there. As I said, I like seeing that this is hard-coding some of the values in there. I personally like to use constants up above for these things, but this is perfectly fine. Now, for pool length, it's just showing you the information on how many pools are set up. This is typically going to be used elsewhere in the system for, well, keeping track of exactly how many pools they have set up. Now, as far as add, we can see here that the add is, well, it is adding in pool information. So this is, again, one of those where only the owner can set those. It's setting the various drain modifiers to show, all right, well, what is our calculation on draining that pool? Or should I say draining the Drac because of that pool? Yeah, it is kind of interesting. It's I like the kind of gamified deflationary aspect to it. I'm always questionable on some of the gamification stuff, because, like, I don't want to play around with the funds, all right? I mean, I kind of do, but I'm not sure I want to get involved in their game. But in this one, it's not like an actual game. It's kind of gamified in the sense that other people can drain this and thus deflate the value of the token. In fact, that's actually why you're seeing, if you look at the price chart for this heartbeat, is there are bots out there that are snapping portions up, draining things, and that's causing these weird spikes and dips in the price that only exist for a moment because, well, that's just the transaction that's executing, and it just happens real quick there with the bot. So, with this, in adding it in, straightforward, they're adding in a pool, they're passing in all the information to configure that pool. So if you're curious on how the pools were configured, you can check the transaction log, you can see what the calls for adding a pool were, and look at the various arguments passed in. Pretty straightforward. Updating the pool limiter, again, just a way to pass in and say, alright, there's a reward pool limiter, let's make sure this thing doesn't get too far out of control. That's why, for example, under the update reward per block, it is double checking that pool limiter to confirm that no one has set this as something too high, which I like, because that means that when they add in a pool, they don't have a way, or I should say when they are setting this up and modifying it, it would be difficult and it would take time for them to try to insert a pool that has the wrong values. And if they tried to do that, it would screw up the entire system. So this is useful. This means that they can't just slip in one reward pool that is rewarding wildly out of whack with everything else. Now, yes, they can update the reward pool limiter. They can change that, but if they do, that's going to change it for everything. So, again, these nice safety checks to say they can't really slip something in without people noticing, and if they try to slip something in, they're going to end up screwing up everything else that is going on. So that's particularly handy. Alright, so in here, they're updating the reward per block. Pretty typical. In this case, they're checking that reward limiter to make sure, okay, are you trying to add or have this thing send out more rewards than we agreed to originally? If so, no. So that's why it's got that less than equals to, saying like, look, you can only reward people so much. It's then updating the pool. We'll see that coming up as far as updating it, and is updating the reward per block. Simple enough. Alright, reward per block massive. This is one when they're passing in an array of all of the pools they want to update and information on the rewards. So this is where they're just kind of sending in that huge amount, saying, look, I just want to update everything all at once. I don't have to keep calling individual update functions. Just here, take care of everything all at once. Do all of these pools together. And so in these cases, they're double checking. All right, first off, do we actually have enough rewards in there to actually update the pools? We do. Great. Let's go ahead and start iterating through the pools here and start updating the pool IDs, or get the pool IDs out, get the rewards out, confirm that we're not trying to reward more than we should, and let's go ahead and update the pools, and then update the actual rewards that are due for those pools. Again, pretty straightforward. In updating the victim info, again, this is adding information about the victim that can be targeted. Again, very straightforward. They're just defining, all right, well, for this pool ID, here is your victim, and they're actually initializing that as an instance of victim for whatever they pass in. So they're passing an address, and they're saying, look, turn that into a instance of this interface, so that way I can, well, more easily interact with it. Again, pretty straightforward. And we saw victim earlier, to be clear, under the vampire adapter. Here we are. And the vampire adapter has that declaration for victim, and then in having the actual interface or the vampire adapter, it has the information on actually calling that. Alright. Now, from here, they have the victim pool ID. They're defining that. As far as updating the pool drain, they have their pool info. So they're saying, all right, we want to get information about the particular pool. Oh, well, thank you. The Hippo trading at $5 down from 20. That makes it, all right, well, I don't know. All right, cool. All I can do is say that something works or not. Whatever. I can't control the market. I can't control the changes. So I can just say whether or not something works. Core seemed to do all right, but I think I think you're maybe wondering or expecting a little too much from how things would jump. All right. Anyway, moving on there, we've got our update pool drain. In this case, it is highlighting that, yep, we are going to be confirming exactly how much should be drained. We're going to look at the pool info. We're going to go through the reward drain modifier and confirm and update that. Same thing with the wet drain modifier. So again, a way to update exactly how that's being drained by, or so exactly what is being drained out of that. Further on with the dev address, boom, able to change that, update the drain address, also again, able to set that. And as far as the update reward updater address, again, going to be able to list in exactly what address is going to be acceptable for updating the pool rewards. Now, from the pending Drac or DRC, we have here the call where they're going to be sending in the pool information. They're going to be accessing the user info behind a particular pool, so that way they can figure out exactly who has that pending Drac. From there, they will be able to pull in that information on, alright, so for this pool, what is the accrued Drac per share? And here, they're doing that check on the LP supply. So again, they're just confirming, alright, first off, which pool are we looking at? Alright, if we're looking at 0, then we're going to be using this one, so the Drac weth pair for this particular address. If not, if that isn't 0, then we're going to go look at that pool victim and see what that locked amount is. Alright? So, for here in the actual check, they're confirming, hey, are we within the block number? So again, this is a check to say, let's not reward more than 1 per block. So they're just confirming what that is, and making sure that there is an actual LP supply to be able to reward off of. Like, there's actually something in there to be basing the reward from. From there, they're just doing that check to see, okay, let's go ahead and from the block number, figure out what the last reward, or last block that we issued a reward on, to figure out what that difference is. Did Save2, aka Cover, contact you to do an audit? Yeah, I can certainly help out with that. I am a little backed up on messages and such, since we didn't get the development resources that we were hoping, so pardon as I might have been a little delayed there, but I will definitely have to check up. I do believe they did, so pardon. Where was I? Right. Yes, so there. In that case, is figuring out the actual accrual per share, doing that by looking at the Drac reward, multiplying that out, and dividing it by the LP supply. Again, the multiplication here is actually accounting for those decimal points and then dividing that out. Same thing with actually returning that. So one point here is that this thing isn't really updating any information. It is just calculating out the pending Drac. And so, as you can see, it's not actually making any changes to any of the particular values. It's just doing some calculations. As far as mass update pools, earlier it was updating particular pools in mass. In this one, it is saying go update all of the pools, hence why it's iterating through the PIDs, is doing that from the pool length, and then saying, alright, go through and update every single one. And here we're at that infamous update pool. So, in updating pool, you pass in the ID that you would like to update. We saw that up above where it's going through each of these. In these cases, it's confirming, alright, let's get the pool info. Got it. Let's confirm that we should actually be calculating and updating the pool right now based on when that last reward was sent in. Then we've got our LP supply saying, alright, first off, are we updating 0? If yes, then go ahead and do that calculation by getting the balance of the Drac weth pair for this particular contract that is doing that work. And again, not making a change, just getting information out of it. Or similarly, look at the locked value for that particular victim. From there, confirming if there is no LP supply, then just go ahead and set the last reward to this one and be done. Because if there's no LP supply, there's nothing to reward, moving on with our lives. So, with that out of the way, and that's what the return value here is meaning. That's meaning, alright, if you run into the return value by any of these conditions being satisfied, just stop. Just, we're done with this function, you don't need to go any further, alright? Now, from here to the block rewards, in handling the block rewards is doing that check on the number, confirming yes, should we actually still be rewarding, correct. It's figuring out how many, out of the blocks to reward, what is the reward per block, so it's multiplying those together to get out what the actual reward should be. Then from the minting, it is actually minting out an amount of Drac based on the reward. So again, this is another example that minting is not necessarily bad. You have to look at how the minting is being used. And I'm seeing this come up more and more in various contracts, especially where they are using some sort of deflationary mechanic to remove or add in, to remove various tokens, or some amount of the tokens based on whatever the tokenomics are. And so this is one where they're kind of minting that out. I actually like seeing this because, one, nobody can call the minter directly. All right, start off with. Second, minting is tied entirely. Cover contract. Yes, sorry, so there. Where are you in collaboration with Team Finance? Oh, yeah, they do have the product launch. I was speaking with them. They have a few different pieces on getting things in place in talking with Team Finance. So they've actually are making a few changes to their various projects, and thus when they're launching out, they are still planning on introducing, or last I spoke with them, still planning on implementing the library that will integrate with a deployment. Even if they don't, we will, to make that easier. And as far as I understand it, the product launch that they're doing now is a complete product launch based on what they've advertised, but they are also adding in extra features coming up, and they're wanting us to review some of that. Actually, already spoke with them earlier and kind of went over the contract and gave them an informal personal audit on the review, and hence they're kind of moving forward. Part of it also was just the scheduling. They needed to delay, then we needed to delay, then there was some rework to be done on their side, then there's some rework to be done on our side, and ultimately it just came down to, look, I'm not sure we're going to be able to sync up entirely. How about we just go ahead and launch? They got audits from other firms that were able to handle that, and we'll just circle back on them with the integration. So, thank you for asking. Where was I? Still good with them, still liking them, still getting along just fine. No problems there, mostly just a timing thing and some of the features getting added in. Where was I? Right, so, in this case, in issuing that out, like I said, with the mint, not bad. In minting that out, it is minting out an amount where it is saying, alright, we're going to mint this and send some to the dev address. So we can see here for the dev fee that we saw earlier, it is multiplying the Drac reward by that and then dividing that by 100. So in this case, it's figuring out the reward, saying, alright, we're going to multiply that by 8, and then we're going to divide that by 100. So they're getting a very small portion out of this, and they're getting it in Drac, which I also like, because now that aligns the developer's interest with the team interest. That also means that the developer is only getting rewarded from based on users interacting with the project. So they are only getting their rewards at the same time you're getting your rewards, which, yes, they could pile them up, yes, they could do something, but that's also where the time lock is coming in. You can confirm where the dev address is, that's moving into the time lock, and thus there's still a delay on that. But again, they're only getting their reward when you guys get your rewards, and it's happening in conjunction. And it's coming out to be less than the actual reward amount that is going out for each of the pools. Pretty straightforward. Alright. Now, from here, after doing all those calculations and after minting some out, they are then updating the pool. And again, in these cases, when they're updating the pool, they're not making any calls to any additional addresses or anything. So again, entirely safe here. If someone re-enters into this, it will identify, like, wait a minute, I already rewarded for this block, therefore should not be rewarding any further in calculating that out. If it does try to re-enter here and try to run some of that, as you can see here, for the block 2 rewards, it's actually going to calculate out exactly what that remainder is, and would then go ahead and modify. But again, you can't really re-enter here because they're not making a direct call to another contract in these cases, at least not after they get through the basics. And then they go ahead and set up the last reward block to say, okay, we've rewarded now, we're done, moving on. As far as deposit, this is where users are depositing things. Again, we're getting information about the user to say, alright, let's get information about the pool. Upon getting information about the pool, let's go ahead and get information about the user. They're confirming, alright, let's update the pool when they deposit, so that way we can dole out any rewards that are necessary. And from there, we can pull in the user amount. We can figure out, alright, what's the accrued Drac per share that they should be getting. We're going to factor that in for the decimal points, and then we're going to go ahead and subtract out the reward debt to say, okay, here is the amount that they should be getting, or are getting, and then from that, we're going to dig in and actually say, alright, how much are they due to figure out what they've been awarded so far, and then boom, we're going to figure out, based on that pending, we're going to give that out to them. Straightforward. For the amount, again, that's if the amount is, or if the user amount is greater than 0. From here, they're also checking to see that the amount to deposit is greater than 0. From there, they are making that call out to the Drac weth pair to do the safe transfer. In doing that, they are making that call or using the message sender, and I like they're wrapping that in address here. So that way, it's kind of like using the message sender from context. I kind of prefer using that one, but this is the same result. Same thing with wrapping this as an address. That's, again, setting up that wrapper to kind of say, all right, look, if you're going to fuck with things in the background, we're going to protect ourselves a little bit by not actually interacting with you. Again, pretty straightforward. If the pool ID is not 0, then this is where they're going to be calling out to the actual pool victim and getting that set up and initialized. Again, straightforward. All right, so from here, they are then adding in the amount to be rewarded, and from there, they are recalculating the reward debt to confirm, okay, we've just figured out an amount to reward to them, we're going to roll that back, so we're going to account for that, and update that reward debt to say what has actually been due to them, all right? Now, on the withdraw, similar points are happening here, just kind of the reverse. In fact, actually, it's kind of everything's happening in reverse. They're figuring out in the withdrawal, they're double-checking, all right, let's get information about the pool, let's get information about the user for that pool, then let's go ahead and confirm what amount are you trying to withdraw. Well, wait a minute, you don't actually have that amount, so we're not going to let that happen. From there, they are updating the pool, so every time you withdraw, it's going to make sure that you have your rewards available to you to withdraw. From there, it is going to, check out the user amount to figure out what the pending rewards are, and again, execute that safe transfer provided you have some pending amount of rewards. From there, it's going to look at the amount that you've asked to withdraw, and therefore it's actually going to subtract out that amount, say, okay, we're going to give you your rewards, then moving on, we're actually going to check to see what that is. Now, in this case, as far as running that down, they are, in doing that pending amount, they are doing the calculation based on what you're due, and then they're confirming from that amount, hey, let's actually confirm, hey, we've got, whoops, pardon there, let me finish that, we've got that amount due. So again, straightforward. In the rest of these, that's where it is doing that check to see, all right, well, which pool are we updating? If it's the Drac weth pair, we'll make the call here. If it's some other pair or some other pool, then we'll actually call out to that directly. And then again, updating that reward debt. Pretty straightforward. Now here where we see that emergency withdrawal. Again, the thing that we were seeing earlier, we're seeing this here on the actual master vampire, and we'll be able to see on the individual pools that are using that victim, that emergency withdrawal. So in this case, that emergency withdrawal, they're sending in the pool ID. When they get to the pool ID, they're saying, all right, let's get the information on the pool, let's get the information about the user. It was pool ID 0, then as you can see, they're doing the safe transfer, and they're sending out that user amount. And so this is an important point here, is that, as you can see, if there's an emergency withdrawal, it's something you guys are calling yourself. So that's where if something goes wrong, if they send out a message, say, all right, there's a problem, go do your emergency withdrawals. As you can see, it's not actually sending it out to the dev or anything. It's something that each of you would have to call, and each of you would get your own portions back out. All right, so that's something useful to notice from before when we were seeing, okay, why did that not make a statement? Well, technically, it wasn't even transferring much of anything. We're seeing here that if there's an actual emergency withdrawal to be done, then it's handling that. And in handling that from the vampire adapter, again, remember, with the emergency withdrawal here, this is just making that call out to the victim to withdraw that and then confirming that it worked. And as you can see here, it's actually making the call to emergency withdrawal. And it's like, okay, well, what is happening here? Well, what is happening here is this is the emergency withdrawal that it's generally calling. As you can see, it's passing the address and the uint, and we have a call later on where, when passing in for that particular victim, we'll see more usage of this here. So to be clear, not exactly the same, right? We're seeing reuse there, but we can get that indication that at least here for the emergency withdrawal, it is passing, or is calling in from emergency withdrawal here, and then passing it out to the person who sent in this message. So you're each going to have to withdraw your own. We'll see the emergency withdrawal later on for things that are actually acting as, well, these victims. So basically all of the victims will have this emergency withdrawal option, and to be clear, the master vampire... Oops, there we go. The master vampire, that's not itself a victim. That itself, we're looking at the vampire adapter and using that for the victim. And so down here, under the emergency withdrawal, we can see that when we're interacting with the pool, we're going through the pool. So again, this is not exactly the same as what was before, or what we were seeing before. We're going to see that used up, or coming up here. But again, in the emergency withdrawal, it is actually sending out to the person who issued that call. As far as the safe Drac transfer, again, this is one where it's essentially just a re-implementation of what we find as the safe transfer in safe ERC. I kind of prefer to see the safe ERC, but that works. In this case, it's doing a basic check to see, okay, let's get the information on the balance of what this thing has, and then confirm that the amount to be transferred is such. And so then this is marked as an internal function, so it can't be called from outside, so it has to go through the other functions to be able to get here. As far as the drain, this is the drain function that we saw earlier. In this case, it is going through, getting information about the pool, treating that as a victim so that it can make those calls, figuring out what the drain reward modifier is, figuring out, all right, how much is the reward that's supposed to be there. So as when it drains, it's claiming the reward off of that. So that's where it's draining out of the available rewards. And so setting up the reward token, confirming which one should be withdrawn, setting up the claimed rewards to see, okay, how much should be, or how much has been rewarded out or could be rewarded, and then from there actually doing the calculation to see, okay, what amount should we drain? If so, then let's go ahead and transfer that to the drain address and transfer that to the, and set up the claimed reward based on how much has actually been taken out. So this way, when it's draining something, it's treating the drain as kind of like a generalized claimed reward. It's not credited to any one person, but it's just saying, okay, some rewards have been collected, and those are drained over there. As far as the sellable amount, it is setting that sellable reward amount to confirm, all right, how much is actually in there, and what can we actually work with. And again, confirming that point of, let's make sure that the sellable amount is less than, if not, like if it's drained if the victim is drained completely, then, well, we're going to have to go ahead and set up that sellable amount and make those equal. Again, pretty straightforward. If it's already 0, then we're done. Don't need to do anything further. If there is any claimed reward left, then that's where it's going through and selling the reward for Weth, alright? In getting that Weth, it is transferring that Weth to the drain address, and then is subtracting that out. Oh, yes, thank you. So, with that, we then can see here that it is moving to the Drac-Weth pair, making sure that that is being set for the... In token 0, it's saying the first token in the pair. So that's why it says token 0. It's referring to, we've got a pair, one of them is 0, one of them is 1. Straightforward. In this case, it's getting that reserves for that. In the reserves, it's telling you how much is actually inside there. Reserve 0, reserve 1. All right? And in this case, it's actually confirming, all right, if... Let's go through and check the address, confirm that the Weth address is equal to token 0. If it is, then it's going to use the reserve 0 and reserve 1. If not, then it's going to flip those. So again, it's just making sure to say, okay, it should be 0 and 1, but we're not entirely sure which way the contract or the underlying pair is going to define 0 and 1. So they're just doing this check to say, okay, which one are you actually referring to? And either way, I want to make sure that we're setting that in the right direction. So that's why we have the reserve 1 and the reserve 2. They're saying reserve input and reserve output. This is just a safety check to say, look, we're not entirely sure what's going to be happening with the underlying pair, because we don't control that. That's Uniswap. And thus, we have to double check exactly which one we're going to be talking about. All right? So from there, we're going to get the amount out. Boom. Set that up for, and this again based on the Uniswap v2 library. So here's the amount for the output, which should be the which should be the one that want to drain. And then here they got the address. All right, let's confirm that we've got the right address and exactly what the amount out is. So amount out and amount one out. And in this case, they are then making that transfer of WETH to the Drac WETH pair for the WETH reward. And then for the Drac WETH pair, they are swapping that out and saying, okay, go ahead and boom, swap. Here is tokens, and go ahead and send that back to me. And then they are burning it. We saw the burn operation for that for Dracula, or we will see that when we get into that token. And so boom, they are burning that amount and just sending that on its way. So that is where they are pulling in. They're confirming, all right, I'm dealing with this Drac WETH pair. I need to get an amount to burn out of there. So let me go ahead and dig through and figure out, first off, which one is WETH, which one is Drac. All right, then let me go ahead and sell the Drac for, sell the WETH for Drac, and then go ahead and boom, send that off. Pretty straightforward. All right, so that is the bottom of this. The other ones, like the Uniswap library, again, this is a library. I was able to confirm that, yep, this is coming straight from Uniswap. This is where it's getting the information on sorting the tokens that are in place, pair for, get reserves, quote. All of this is basic operations on Uniswap. So that's why it's marked as a library that they're able to use. It's not a contract in and of itself, because this is just saying, let's make it easy to talk to Uniswap. Not, this is Uniswap. So again, this is all standard implementation, standard place. You can actually check the Uniswap repository to see the information in there. And it's not really making any changes. It's just saying, all right, I need to get information out about this, and I need to be able to check to see what the value and the pricing would be. We've got our standard safe math, pretty straightforward, standard implementation, nothing special going on there. We've got an adapter. Adapters are interfaces, I should say, that is an adapter. Interfaces don't do anything. So, to be honest, we really don't have to care about them. We can just kind of move on through all the interfaces, because all they do is define functions that should be implemented. They don't do anything. They don't have any intelligence. So there's a lot of interfaces here. We can just kind of move on from them. And again, I'm not trying to breeze past it. It's like, literally, there's nothing there to check. It's like, oh, okay, you're a thing that makes coding easier. Moving on. Now, here we've got the Dracula token. Pretty straightforward. Yes, they're using Mint. Mint is fine and appropriate, especially based on how it's used. In this case, we saw earlier that the minting is handled as part of doling out the rewards. So technically, and you can check the logs, the owner of Drac is the Master Vampire, and the developers don't have a way of just calling Mint on their own. Technically, anyone can burn an amount, but if you want to burn, you're only burning your own, all right? So that's where, in doing this, it's saying, look, how much do you want to burn? Cool, I will burn the amount from whatever you have. From the before token transfer, it's just confirming that if you have set up a delegate to be able to transfer for you, then doing that confirmation of like, all right, well, who is that, and let's actually make sure that they are set up to do that appropriately. And again, this is something you're setting for yourself if that occurs. Moving on for the delegates, again, delegates for being able to make transfers. This is partly how they're having various things internally in the process be able to manage some of the other internal processes. But again, all of this is being set by the person calling. So this is one way to handle the approvals. You know, you see approvals on other projects. They got the same thing here, but they're kind of defining, look, we can, if you want to delegate the expenditure of your token to something else, that can be done. Mind you, this is all internal, and thus is really intended for the internals of the system, because it's not really something that can be used outside of that. Like I said, it's basically a way to say that the various contracts that make up the architecture can talk amongst themselves and spend each other's tokens. And as we've gone through, we can see that, yeah, they're actually handling that properly, and there's not a way for anyone outside the system to make that call. All right? So, from there, we've got various mappings and such, calls to delegation, simple enough. We have the delegates that are being operated on. This is just getting information about those delegates and the delegator. So if you really want to get that information, you can. And this is a way for a message sender to delegate the expenditure or use of their contract from one to another. It's mostly used internally, but technically you could do this yourself if you wanted to let someone else be able to vote on your behalf. So again, this is not token expenditures. I want to be clear here. I was saying this is kind of like approve in being able to say you're approving something else to spend some of your tokens. This is approving someone else to vote on your behalf. So they're not going to be able to spend your voting tokens. They would just be able to vote with your voting tokens. That is entirely different. And you don't need to do it, but if you do set up an organization yourself and you want to delegate that responsibility, boom, you can do that here. And so delegate by SIG, just another way of delegating, lower level where you can actually pass in the signature of such things and set that appropriately. Pretty straightforward. Also, keeping track of the nonces that are being done, again, is a bit of defensive programming there. As far as getting the current votes, that's just a view. It's just saying, all right, what are the votes that have been cast for any particular contract? So, pardon, I got a meeting coming up here. I'm not hurrying through, but to be clear, there's not a whole lot left to go through because we're already covering the Dracula token, and then everything else that is in here is really just interfaces that are facilitating the interaction with other platforms. And a lot of those aren't even necessarily need to be used yet because, well, they're integrating with other exchanges that aren't quite set up. So, getting prior votes, getting information, again, this is just getting information about the votes. So no changes being made here. It's just looking up to see, alright, what votes have been cast by the various addresses and what was the amount there. Similar point with delegate, internal, this is what's actually handling the delegation. It's adding in the delegator, defining who the delegatee is. So if I want to delegate my votes, this is going to set it up and say, alright, here's the array that has the information for who can be able to vote. And as far as moving the delegates, that's where it's saying, all right, if a delegatee, all right, yes, if the delegatee, the one being able to vote with other people's tokens based on what you guys might say, if you want to see that ability, boom, you can do that. This, if the delegatee needs to change that and say, okay, well, I can't use the old address that I was using, I'd like to use a new one, this is a way for that call to happen and say, okay, we're going to remove them from the old representative and we're going to add them to the new representative. And again, this is something that when a delegatee is saying, look, I don't want to vote with the old address anymore, I want to update to a new address, a way for that to be done and move those over. And again, in this point, as we saw earlier, something that only the person actually that is the delegatee can call. As far as writing the checkpoint, this is just keeping a checkpoint on the votes. So you can see what the old votes are, the new votes are. That way we can keep track of exactly what the votes were for any particular block if we actually need to keep that track. And further, getting, just safe 32, basic safe math operation for actually making sure we don't have an overflow error, and similar thing with chain ID, able to get information about, the actual chain that's working with. And everything else that's here is really just various adapters, interfaces, and interfaces that are making calls out to external systems. And so even when you look inside some of the adapters, they're saying that they are, boom, making calls out to the great content. Oh, well, thank you. I'm very glad you're appreciating that. I know some folks like to give me shit, like the guy talking about Grim Reaper. Don't know how serious you are. I hope it's teasing, either way. But in that case, like, what can I say? People are going to trade, and I generally consider that part of that is people selling off, because usually by the time they get around to me doing an audit, it's usually about the time rewards are selling. But I am glad that people are understanding and liking what they're seeing, that they're able to understand and get helpful info, and from there that, as far as checking out SysRise, have them contact me on Twitter or have them email audits@chain.church, and we should be able to get something set up for them. Trying to work on getting other auditors trained, but there's just so much work to do, and did not get the development resources we were hoping as quickly as possible. But that's fine. We've got some other projects in place that should help us get some funding, and that should be able to straighten that out. So again, here in the YFV adapter, this is an example of what they're doing, where they're making calls out to some external system. Things like selling the reward for WETH, where they're, like here, dealing with the sushi reward that's over on Sushi Swap. Basically doing the same thing. We're like, alright, well, we'll sell the reward for WETH and be able to get the WETH out. Again, the whole point of this being, as you saw earlier, that when interacting with the victim or making those changes, it is actually going to be going through that buy and burn process to send it out and get the weth back. And again, this is all based on selling the reward, not the underlying token, to be clear. This is about saying, all right, I want to sell the Drac for the underlying weth, and then and then be able to keep that weth and burn that Drac. All right. So again, all of these are basic operations. You saw here from the master vampire pool where there was already seen many of those functions being called. And so as you can see, not a whole lot going in here, and everything from here is really just interfaces that are making it easier, or simplifying the calls out to other systems. So pretty straightforward. So with that, there is not really anything else to go through. Like I said, it's all interfaces. Interfaces don't really have intelligence, and therefore there's nothing to check there. We already saw the use and implementation of those interfaces, and some of the stuff that is in here are things that are coming up. Like, for example, when we look over at LewisSwap, we can see that they're still all talking to Uniswap v2. So even though they've got options here for some of the other things that they could be talking to, they're either not quite integrated with all of those various exchanges yet, or in looking at the integration, it's, well, straightforward, and same with the others. So with that, that is the review. So Drac is safe, Drac is reliable, there are no vulnerabilities that I can see. Any of the calls that were made out in the MythX analysis that I used as a guidepost to start things off, along with Slither, really were just very basic cautionary warnings to say, hey, would you please, please, please make sure that you're doing this properly? I'm not entirely sure what you're doing. Well, I went and looked, and not a problem. So, unfortunately, I am terribly busy. I wish I could stick around and hang out more, but those alarms were meetings that I need to get to. So, unfortunately, I do need to run. Thank you all. I appreciate you signing in. I appreciate you watching. I hope that has been enjoyable for you. And otherwise, good luck in your trading, and may your bags be always full. I will see you as soon as